Okay, you see now, the switches can filter also. If the source and destination MAC address of the incoming packet is same port, it will filter. If it is in different port, it will forward. If the destination address is not there in the MAC table, it will flood. All this we learned. Now we need to understand a terminology called broadcast domain. What is domain? Domain means a group. 10th standard is one domain. In a school, we have many domains. Second standard, that is one group, one domain. You see, in a school, you have various classes. Likewise. In a switch also, you can have various domains. But by default, in one switch, all the ports, let's say this is a 96 port switch. We have 96 ports. When all these 96 ports are in one group, if all the 96 ports are in one group, it means the switch has got single broadcast domain. By default, switch will have how many broadcast domain? Only one. There is another term called collision domain. Tell me, when will the collision happen? Will the collision happen if MAC address of all connected devices learnt in a MAC table, or it will happen when flooding happens? I'll repeat. All these devices are connected, let's say A, B, C. The switch maintains the table called MAC table. It knows A, B, C, D. It knows everyone who is where. Will collision happen in this time, or when switch don't know about the destination, when it is flooding, collision will happen? When will collision happen? If switch knows who is connected where, will there be a collision or not? When the MAC addresses are learned, collision is avoided. Do you agree or not? So the MAC address is learned on every port, which means collision controller, how many? 96. Collision controller. For the word domain, you can use the word controller. Broadcast controller. By default, I told you all port belong to one group, one domain, one broadcast control. Meaning, if this guy is broadcasting, it will go to all 96. Because he is sending what? Broadcast. If he is sending broadcast, it will go to all. But if he is sending a unicast, A is sending traffic to C, it will go only to C. It will go only to C. It won't cause collision. Collision is controlled. How? By learning MAC addresses. Switches have got how many ports? 96 ports. Sorry, how many ports? This switch has got 96 ports. So how many collision domain? 96. But if a broadcast comes, it goes to everyone because it's a broadcast. The meaning of broadcast means what? Send it to everyone. Send it to everyone. How many? Here the maximum is 96 members only. If A is sending, it will go to 95 members, which means all these 96 people are in single broadcast domain. All these 96 people are in single group, single broadcast domain. Did you understand the difference between collision domain and broadcast domain? In a switch, each port got a collision domain. In a switch, by default, all ports belong to one big group, so one broadcast domain. Now I want to tell you, in a router, each port has got one collision domain, one broadcast domain. For example, if A is sending a broadcast, it will go here, it will go here, it will go here. Will it go through the router? No, it will be stopped here, which means this is one broadcast domain. This is another broadcast domain. This is another broadcast domain. The layer 2 broadcast will not be penetrating through layer 3 router. Layer 3 router will not allow to penetrate because this is one network, this is another network. Broadcast of one network will not go to another network. Broadcast of one network means what? Within the network, LAN. Why it will go to another network? It won't go. In router, each port has got collision domain and broadcast domain. Whereas switch, each port has got a collision domain, but the broadcast domain is only one for all the ports in the switch. I want to give you an exercise. You try answering this. I have 24 port switch connecting to a router, connecting to a switch of 48 port. Let's say this is Ethernet 1, Ethernet 2. Right? Now, tell me in this switch, how many collision domain, how many broadcast domain? Exactly. Very nice. Someone else try how many collision domain and how many broadcast domain this switch has got. Yes. Now, in this router, how many collision domain and how many broadcast domain? Okay. 2 collision domain. Very good. 2 broadcast domain. Now you see, these are all correct. What you said is correct. Now, if someone is asking, what is the total number of collision domain and broadcast domain? You see, this broadcast domain is shared here. Broadcast domain is up to here, 24. This broadcast domain is up to here. 40. This is what your answer should be. 48 plus 24. Is it 72? Yes. Don't say 74. Did you get my point? Because the broadcast domain of this switch is up to here, and it is being this broadcast domain is shared. This is shared broadcast domain. You understand or not? It is not 74, it is 72. You got it? In total, only two. This is one broadcast domain. I told you it is shared one. Don't say 4. It is 2. One LAN, it's one broadcast domain. You got it? So 72 collision domain and 2 broadcast domain. Is it understood? And this is an important question in CCNA exam. This question will be always there. I know for 18 years, the CCNA exam, you will always have this type of question. Okay. Any doubt? Now let us move on to the next level. You see, I told you a switch will have one collision domain, one broadcast domain by default. I told that each switch will have one broadcast domain. Now, if I have 92 ports, if all 92 are in single group in your school, if all the students are in single group, is it easy to manage? No. You cannot even teach them because not everyone is in same age. Age-wise, you divide them so that you can teach them to their level. That is how the classes we have divided in schools. Classes. We have different classes so that different levels of delivery can be done by the tutors. Because everyone not the same level. It is easy to manage if you have multiple classes. Even if you take, fourth standard, you got section A, B, C, D, Y. If all 100 students are in same class, difficult to handle. So we divide 20 in each section. Though they all belong to same age group, same level of understanding, we put them in different classes, in different sections, not different class, same class but different section. That makes the teachers to teach more effectively, handle the crowd easily, identify the student's problem very well. If all 100 are in single class, knowing about student will be difficult. Some student may need special attention. In a large class, it is difficult to identify that special attention needed students. So when they put in different section, those necessary things can be identified and better learning experience can be given. Likewise, if this 96 port switch is in one broadcast domain, we just learned by default all port belong to one broadcast domain. We just learned it. By default, all belong to single broadcast domain. We just learned it. but it is difficult for management. It's difficult to um, use it effectively. For example, if all this 96 port are in same department, it is okay. All 96 port, they are connected to the members of same department, it is okay. But what if they belong to different department? I have connected these three to HR, means 6 ports, and this to security team, this 8 backend team, this 6 to admin management. Now you see, we have different role people. They have got different roles, and I have grouped them as admin because they all do admin role, and I've grouped them as production or backend people because they do the backend work. Production people. I've grouped them as security team because they do security role, and I have grouped them as HR because they do the required they build teams, they choose people. Now you see, if they are all in single broadcast domain, if the security team send one packet, and if the switch don't know the destination MAC address, what it is going to do, it is going to flood the packet to all 95 ports, which is not at all needed. The security guys, they are only 4 people, 4 computers. Why is the traffic that is generated in a security team going to HR and management and production? That is not appropriate. That is a waste of CPU, waste of port bandwidth, waste of the backbone throughput. Not only that, the devices connected to HR, the devices connected to production, the devices connected to management, they all will receive this broadcast, which is meaningless for them. The security computer is searching another security computer, trying to communicate to another security computer. And the destination MAC address is not there in the MAC table. Switches will flood the traffic. That is what we learned. If it is flooding within the security group, it is good. But by default, all 96 ports belong to same broadcast domain. The flooding goes to HR, production, management, everyone, which is not acceptable. Why? Because the flooding goes and consumes this bandwidth, this bandwidth, this bandwidth, and this guy opens the packet and say, hey, it's not for me, let me drop. Unnecessary CPU. Not only that, on the switch, unnecessary backbone throughput wastage, lot of ACI chips involved to flood to everyone, CPU. These are not acceptable. But this happens because of this one thing. All ports are mapped to one single group. So what we need is, we need to find a way to put them in different group. In another word, For HR, I need one broadcast domain. For security, I need another broadcast domain. For production, I need another broadcast domain. And for management, I need another broadcast domain. How do we achieve this? By creating virtually LANs, VLAN. By default, all 96 ports belong to one broadcast domain. What does that mean? By default, they all belong to VLAN 1. Switch is a LAN device, LAN. All ports are mapped to a number called VLAN 1. That is the name of the broadcast domain. Now what we are going to do is we are going to create VLAN 10, VLAN 11, VLAN 4, VLAN 3, something like this, and put all the ports of HR in this 11. All the ports of security in VLAN 4. And all the ports of management in VLAN 10. And all the ports of production in VLAN 3. By doing so, you can isolate each department from one another. After doing that, let's say HR port number 1 to F0/1 to F0/6 and security F0/7, 8, 9, 10. F0/10. When you do that, what happens? When a broadcast packet goes to this port, it will be flooded only within this four ports, 7, 8, 9, and 10. It won't go to the other ports of other broadcast domain, which means inside the physical switch, you have created multiple virtual switches. One VLAN is one switch. By creating more VLAN, you created more virtual switches. One VLAN is one broadcast domain. By creating more VLANs, you have created more broadcast domain. Now, if a manager tries to talk to another member of the same manager group, it is possible. But if a manager wants to talk to production, not possible. Why? They belong to different broadcast domain. All these 6 people can talk each other. But this one cannot talk because they belong to different VLAN. If they want to talk, what is needed? We just learned each port on a router is one broadcast domain. So you need to connect one of the port here, one of the port here, so that management can talk to production, and production without router communication between VLAN is not possible. Without router, it's not possible. We'll not talk about that now. It is too early. Now I'm just trying to explain you what VLAN is. VLAN benefits we have seen just now. VLANs help to break down large broadcast domain into multiple small broadcast domains so that devices can be grouped according to the role so that we can increase the security. How? Management cannot talk to production directly here. There is a security. How? By creating different VLANs for production and management, we isolate one from the other. they cannot talk without a router. In the router, we will write access list saying who can talk and who cannot talk. So there is a security here. When there is no VLAN, management can easily talk to production without ACL, without having a router. Now management can talk to security team only with the router. Only if the router access control list that you learned allows. If it don't allow, cannot talk. VLANs improve security. Not only that, VLANs improve bandwidth. Can you believe it? What? Bandwidth? Yes. VLANs improve bandwidth. See, when there was no VLANs, when by default you used this 96 port in this one single VLAN, the flooding in this port was disturbing every link and consuming the bandwidth. Now you don't consume the bandwidth of other VLAN members. That is how you improve the bandwidth. You avoid wastage of bandwidth, which is reflecting in improvement in bandwidth. So bandwidth is properly used. It increases bandwidth. Earlier, when there was no VLANs, always flooding, always going, whenever flooding happens, whenever an unknown destination is there, switches used to flood. And it goes to every members of every department, which is a waste of bandwidth. Now we avoided that wastage of bandwidth. In another word, we have improved the efficiency of the switch. The flooding happens only within the security team, not disturbing any other team member, so their bandwidths are not at all wasted. So VLANs are nothing but grouping the ports into small groups called broadcast domains or VLAN. Each VLAN is one broadcast domain. Members within the VLAN can interact, can talk. Interact means talk, no? Communicate. Members between different VLANs need the help of a router. Without that, they cannot talk. Now, creating more broadcast domain is good or bad? It is good. When we create more broadcast domain, we have more broadcast domains, which is avoiding the flooding of packets to all the ports. VLAN is breaking down the large 96 broadcast domain into multiple small groups, broadcast domain. Some group may have 10 ports, some group may have 4 ports, some group may have 8 ports. Depending on your requirement, you can do the port allocation to the VLAN. You can allocate any number of ports to a VLAN. By default, all ports belong to what VLAN number? 1. That VLAN you did not create. It will be there. And you cannot delete also. And the name of that VLAN is default VLAN. Every VLAN can be given a name. You can create VLAN 10 and name it as management. You can give a name. If you don't give a name, it will automatically take one name. I'll show you when we do the configuration. So you create VLANs and you give name. When you don't create VLAN, there is one VLAN already there to which all ports are mapped to, and that VLAN is VLAN 1. The name is default. You cannot even change the name of that VLAN. VLAN 1 is already created and it is there when you buy the switch. You cannot delete it or modify it. You can create up to 4096 VLANs in a switch. 4096. That the VLAN number 1 is default. You no need to create. But VLAN 2 to 4096 you can create. But not all switches will permit you to create this many. Money is involved. Cisco normal switches, they only support up to 1005. You can create VLAN 2 to 1005. But which is more than enough for many companies. You don't need too many VLANs. This 1005 VLAN itself is too much for most of the companies. But in a large data center, you may need 2000, 3000, 4000 VLANs. They buy big devices and they pay more money in those big devices. It will allow to create even up to 4096. But there is no other number called 4097. No switches on the earth, whether it is Cisco or non-Cisco, will not have 5000, VLAN number 5000, VLAN number 4097. No, not possible at all. As per the industry standard worldwide, this is the maximum, 4096. Is it understood? Now I'm just connecting the wires. F01, first computer is connected. F02, second computer is connected. F03, third computer is connected. And the IP address that I'm going to give here is 10.0.0.1. I told you by default all ports of the switch will be member of same broadcast domain. Same VLAN. Same VLAN, same broadcast domain. Okay, one VLAN is one broadcast domain. I want to show you that. Now all these three computers belong to same broadcast domain. That's what I want to show you. You see, this is the verification command. Remember this command, show VLAN brief. This is the only command you need to know to verify VLANs. You see, all the ports 24 plus 2 gig Ethernet port, all port belong to the default VLAN, VLAN number 1. These 4 VLANs you ignore. Though it is configured by default, these technologies are old technologies, no more supported. FDDI, token ring, these are all very old technologies. And there is a VLAN number called 1002, 3, 4, 5 reserved as per the standard. So you cannot use these numbers because they are all reserved as per the standard. Reserved, though it is an old technology, you are still in the same standard. You have to follow this. You should not use these VLANs unless you use this token ring technology or fiber distribution FTDI technology. These are all மலையேறி போன கதைகள். But இன்னும் மலை அங்கதானே இருக்குது. You need to consider. This is standard. You cannot remove this. You cannot say the technology is over. No, we can start using 1003. No, that's not possible. Given is given. Now, you have freedom of configuring from 1 to 1001 now. You see, initially I'm not going to create VLAN. All these 3 ports, 101, 102, 102, are in same VLAN 1. So if I assign IP address, they will start pinging. Right, now, If you try pinging, they will ping because they all belong to same VLAN. All ports. Let me try pinging from here. Ping 10.0.0.3. It is pinging. Ping 10.0.0.2. It is pinging. Now, yesterday you might have noticed in the MAC table, the VLAN number is also mentioned in the MAC table. What is the command to see the MAC table? Show MAC address table. See, VLAN number. All three ports belong to same VLAN. Now what I'm going to do, I'm going to put this port F03 in different VLAN and show you. Interface before that, let me show you the MAC table one more time. Show MAC address, VLAN table. Show VLAN brief. Now I'm going to put this, I'm going to plug it out, take it away and put it in another box, another broadcast domain, another VLAN. And that VLAN, this is how we create VLAN 10. Name, management. Name is optional. If you don't give, it will take its own name. Okay, now go to that interface F0/3 and say switch port access VLAN 10. This is how we make the membership. This is how we do VLAN membership. This is how we put one of the interface in a VLAN. Did you get these commands? Did you understand what am I doing? I am doing here. You should know the meaning of the commands. You should know why we do this. Did you understand these commands? Is there any question? Right, now we have taken that port and given to VLAN 10. Let's go verify this. Show VLAN brief. You see 03 is missing. After 2 is 4. It's here. You see? It is taken and given to another group. Now if you ping, the ping won't happen. Earlier, you were able to ping this 10.0.0.3. From 10.0.0.1, the first computer, you were pinging 10.0.0.3 successfully. But now if you try 2, it will ping. 2 is still in same VLAN, isn't it? 1 and 2 are in same VLAN. They will ping very well. This 2 will ping very well. Let's ping. 2 it will ping, but 3 it cannot ping. Why? Because that is a different broadcast domain. It won't ping at all. Not possible at all. Total isolation, grouping, that is VLAN. What is VLAN? You should not say what to say. You should tell in your own words whatever you learned now. VLAN is grouping of ports into multiple groups, multiple broadcast domain. Each VLAN is one broadcast domain. VLAN isolates one group from the another. VLANs improve security. VLAN increases bandwidth. VLAN is logical grouping of interfaces. VLAN is creating multiple virtual switch instead of physical switch. All this you should say. Now, let's go to the switch and see. Show MAC address table. You see, the packet didn't even go to 03. The MAC address is not learned, which means the packet did not go. Now let's go to this guy and try pinging 10.0.0.1. The ping will not happen. Even though the MAC address is known there, it will not ping. Why? Because they belong to different VLAN. I'll show you. You see, even though it knows this guy is not pinging this guy because they belong to different VLAN. You see, not pinging. Did you understand VLAN and the power of VLAN? Let us connect another computer, 10004, and put it in VLAN 10. Which interface I need to put in VLAN 10? F04. So I go interface F0/4, switch port access VLAN 10. See, you don't need to say no shutdown on the switches. By default, all ports are up only. Only on the router you should say no shutdown. All right. Now let's go and check the VLAN table. What is the command to see the VLAN table? You see, 4 is also now added to this. It's removed from here. Now, if I ping from 10002 to 10001, I will ping because they belong to same VLAN. But pinging 10004 is not possible. Now let's go to 10003 and try pinging 10004. You will be pinging because they belong to same broadcast domain. What is this? Did I give IP address 10.0? I didn't give IP address. That's why. Sorry. 10004. Again, from 10002, the ping won't happen. The ping will not happen because they belong to different broadcast domain. 10002 is in VLAN 1, 10004 in VLAN 10. These two are in same VLAN, so I go to here and try pinging, the ping happens. Now check the MAC table. You see, these two will ping because they belong to same broadcast domain, and these two will ping because they belong to another broadcast domain. So virtually there are two switches in this physical switch. You can create up to 1001 VLANs. You have only 24 ports, 24 plus 2. Not necessary. We'll talk about those things later. Now, you need to do a lab like this. Create like 3-4 VLANs. Put 2 interface in each VLAN. Sorry, 2 host. That's what interface in each VLAN. Verify this, try pinging these things. We'll continue this VLAN, one more day of VLAN in a large scale. And then we will get into another topic after that called STP.